Thank you for joining us for another ASTQB webinar. Today we're going to cover business requirements and how they're used to drive development with behavior-driven development, also called BDD, and its predecessor, test-driven development, or TDD. During this webinar, we will walk through the steps of taking a user story and applying BDD or TDD on that user story to develop it and recognize in every step how the development is testing focused. Our speaker is Tahida Parveen, and Tahida, I always get your name a little bit messed up, so feel free to correct me as we go through here. But she is a PhD and a very prominent and well-respected presenter. She's presented in many different countries and places around the world, and she is in fact a lead instructor at Thinkful, a New York City-based startup that is focused on the online education experience for tomorrow's developers. She is also faculty and past university department chair of software engineering at Kaiser University. In addition, she is an ISTQB certified tester and instructor at foundation, agile, and management levels. As if that weren't enough, she's also the vice chair for the foundation level certification working group of ISTQB, and she serves as a member on the board of directors of the American body for software testing certification, which is ASTQB. So with that, go ahead and take it away, and we're very excited to have you doing this presentation. It's a sold-out presentation, and it's obviously a great topic.
Thank you, Dave. Thank you guys for coming and listening to me today. And I'm actually going to talk about TDD and BDD. And when I started this presentation, I thought, well, maybe I should go the other way. And then I changed my mind. So now you're going to get your dose of TDD first, and then we'll go to BDD. And I'll explain every one of them as we go. I think Dave did a wonderful job in basically telling you guys who I am. And I just wanted to let you know that my PhD research was in software testing, cloud computing, and system migration. And, you know, we as presenter like to kind of tell everybody what we have done. And among many other things, I've also published books. And so they're called Software Testing in the Cloud. If you're interested, you can go and look at them. I am an independent consultant and trainer at various in various topics such as testing and development as well. So why do I want to give this talk today? I like to start my talk with Dilbert cartoon. As you know, we as software engineers and software testers, you can pretty much find any topic that you're looking for. You can find a Dilbert, equivalent of the topic that you're thinking about, you want to present. So this is your today's dose of Dilbert on TDD. The reason I wanted to give this talk is because we hear about TDD, which stands for test-driven development, and you may also heard it as test-first programming. And it's it's very popular in certain certain teams, but then we as testers, we wonder, well, we've heard about it, but do we really know what's going on? Do we really understand how it works? Do we even know why it's beneficial? And then, not that we are a master of TDD. Before we can be a master of TDD, we hear this thing called behavior-driven development. And now you're like, well, it's TDD, BDD. Well, what do we use? Which one do we use? Do we use one or the other or something else? So I want to give you sort of an introduction to both TDD and BDD. I do want to go into detail. So I'm going to show you some code as to how a program is developed, or a feature is developed using test-driven concept, writing the test cases first. And then later on, I would also like to show you guys how you can take a user story and then actually apply the behavior-driven development concept to build the product. And we'll also talk about which one is better or worse, or when to use what. And in between, I would also like to talk about two other topics. One is unit testing, because really the concept of test-driven development, I can't really explain that without talking about unit testing, where a TDD is mostly applicable. And then I would also like to give you sort of a reminder as to what acceptance testing is, because without understanding or knowing the value of acceptance testing, behavior-driven development is really of no use. So those two, from a testing point of view, as I talk about TDD and BDD, think about those two levels, testing at component or unit level, and then testing at acceptance level. So if you guys have taken the foundation certification, for the ISTQB, or if you have taken the Agile certification, you're very familiar with this, this description of test-driven development. It's a way of developing software. And in this concept, we actually create the test cases, write the test cases before we even write the software. And the misconception is that people say, well, that is how you test software. Actually, TDD is not a testing concept. It is actually a development concept. TDD is how you develop software. And so that's number one. That's really important to understand, that it is a way to develop software. And now, then why do you call it testing? Because you want to use testing as the driver, right, in order to develop the software. So, and then of course there's other misconception which says, well, we have tested this, so now call it what you want. We have written test cases, therefore we don't need any other testing. Well, that's not true either, because using TDD, you are only able to test a very, very small piece, which is a component. A system or a software consists of a lot of components, and we also want to know how you test, how the whole picture looks like as a whole, rather than just a small component. TDD is, as I said, it's a development concept. It is also a design strategy. So as I go through the example, we will see that as we write the test cases, and as we write the code that will pass those test cases, it actually helps us create the design of the code. It actually helps us think about design. How can we write better code? And people who follow TDD are known to pretty much have better design. They have much better handle of their code. They actually keep design in mind before just blindly writing code. They do have more confidence in their code. They can change them easily. They can play with them, and they can actually figure out, because they're writing the code against a test case. So their goal is to make the test case pass. Now, people would say, well, what if the test case that you wrote is wrong? Well, yes, we will run into that, and yes, you have to test the test case to make sure it's correct. But that is one of the other reasons why you cannot only rely on TDD, just doing component level testing. You would have to rely on system testing as well. So given all of that, you can think that, well, who is really who is the person who looks like is more responsible for this kind of activities? And that is developers, right? So developers are going to be applying TDD to develop their code, and that's how, in a perfect world, that is what should happen. It is a developer's task. Doesn't mean that the testers are not involved. Again, as a tester, you should at least know the concept and how it works. so that you can convince the developer if TDD is not already part of your team, or if it's not applied, if your developers are not following it. So as a tester, you should at least have the concept, even if you're not doing this on a daily basis. In TDD, one main factor is, we call it the red-green refactor. What that means is that so first of all, you write a test and there is no code, nothing, right? The first thing you do is you sort of have an idea of the feature that you're going to implement. And based on that, so that's your requirement. And given that, the first thing you do is you come up with a test case. And that is hard. It's not easy, especially for a developer who's used to thinking in sort of a forward way, like creative way, right? This is how I'm going to create things. And now you're actually thinking in sort of a reverse way. You're thinking, well, how, what is it that's going to make this pass or make this fail, right? So you write a test, and then you run the test, and of course the test is going to fail because there is no code there for that test case to apply the test on and see if it passes or not. There is nothing. So you're basically writing a test case, and it's failing. And so that's what the red is. It actually shows you a red bar that says this test case is failing, and that's okay. The first time, that test case is going to fail. Now, your goal is to actually make that red green. And the way you're going to do this is you're going to start writing code. And as you write code, you're going to click the button, right, to see if the test case is passing. And within the second try or the third try, it's still going to be red and red and red. And at some point, as you finish writing the code, that test case is going to turn green, which means now you have the code that actually passes the test case. You have a component and you have a test case that actually tested the component. And as you move on to the next component and the next component, you follow this process. So imagine that you have, 1,000 components in your product. And now every one of those has an associated test case. And the assumption is that means that every one of those components has been tested. Now, they may not have been tested thoroughly, and that's okay. That's fine. This is only the first step of developing, your product. So it's okay if they're not thoroughly tested. We don't need, 5 different test cases for just one component. 2 is enough. Right? It's a very quick way to sort of make sure that the developers, there's no developer's mistake or error in the code. Okay, so that's like the general idea. So if you hear the red-green refactor or the red-green cycle in TDD, that's what it means. Fail, write a test, fail the test, write the code, pass the test. Okay, all right, so that's all concept, and you guys probably have heard this before, so that's all good. Now let's actually do the task. Let me just walk you through an example so you actually understand how to apply this. Okay, so here is my very loose user story or loose requirements, and we're going to write a program or an application that actually does FizzBuzz. So if you don't know what FizzBuzz is, it's basically a learning game that we use. Kids or young, like young developers, entry-level developers, basically, who are just starting to write code. We use this as a way to sort of get them to write code, and more importantly, understand multiples. So you're going to write a program that basically takes an input, and then you're going to start from, like, let's say that input is 25, right? And what I'm asking the program to do is tell me from 1 to 25, right? Take each of the numbers, And if you find a number that is a multiple of 3, you're going to display fizz. If a number is a multiple of 5, you're going to display buzz. And if a number is a multiple of both 3 and 5, both, then you're going to display fizz buzz. And if it's none, right, then you're going to basically show me the number. So let's say this is a requirement you get from your customer. And of course, as a tester, we like acceptance criteria. We want to know how the end result should be, right? How it looks. So here is an example of if I input 25, this is how it should look like, right? 1, 2, and then fizz. 3 is a multiple of 3. 4, and then 5 is a multiple of 5. And then 6 is a multiple of 3, and then 7, 8, 9, and all the way to 15, which is a multiple of 3 and 5. So that's giving me fizz buzz. So the output should look like this. So now you have a requirement in mind and an output, how it's supposed to look like, right? So let's say, I'm a developer and I start coding this. If I were not using TDD, initially what I would do is basically I would start writing my code, and I would start putting all the logic and everything, and then my code will become this large file with all the logic that's in there, right? But that's not what I'm doing. I am going to apply TDD, which means the first thing I'm going to do is write a test case. So well, how do I write a test case, right? What can be some of the things that I want to find, I want to do as I am implementing FizzBuzz, right? So I could start with fizz, right? I could say, well, and then I could even go, I could just start by saying, does it actually test for a number, right? So I could do that. And here, for time's sake, I've simplified this to basically 3 or 4 test cases. So let's just say, I'm going to start by testing for fizz. So how do I do that? Well, if I enter a number and that's a multiple of 3, it should return fizz, right? That is the very basic requirement I'm going to start with. Okay, so I'm going to write a test. And then I'm using Java here, but you can use any language you want. Again, if you don't know programming, not a problem. All this is, as you can see, it's very simple coded. It's supposed to be simple. Notice that all this is, it's a function, and there's an assertion statement here that says, by the way, whatever is coming out of this function call, fizzbuzz.getResult, right? Whatever is the return value of that should equal to the string right here called fizz. And I said, okay, so I want to find out if I'm going to test for fizz. And 3, if I enter 3, it should return fizz to me because 3 is a multiple of 3. So again, notice that I'm not trying to break the product. I'm not trying to come up with a lot of sophisticated input or anything like that. Very, very simple. Does the product work? Does it not work? And that's it. So here, this is my happy path test. So I write this test case, and of course I'm going to run it, and it's going to fail. It's going to give me a red because I don't have any code to actually test this, right? But notice that as I wrote this, right, as a developer, I thought about some things. I thought about, well, I should have a class called FizzBuzz. Within the class, I should have a function called getResult, which should take an input, which would be an integer input, right? So notice that as I am writing this test case as a developer, I'm actually thinking ahead, and I may even capture those thoughts in sort of pseudocode or comments in my code, right? So that's the design part of TDD, is you don't blindly just write. You can't blindly write test cases. You've got to think about the structure of the code that you're going to write. And so that's what I'm thinking, right? I'm actually designing the program as I do this. So now the test fails. So what do? I'm going to now start writing my code, okay? So here, notice that again, I said I was going to have a class called FizzBuzz, right? And then which I do have here. And then I said, okay, I'm going to have a function called getResult. And so which is what I have. And I said, well, my function should take an input, which should be an integer. And that's what I have, right? And then within that, and I would use a couple of steps if I need to write this logic here. All I said here is that, well, if the input does not give me, if any remainder, that's what the mod is for, right? Then it should return fizz, okay? So here, and of course, after one or two iteration, I write this and this one passes. So notice that this is test, and then this is the function where I implemented all the logic to pass this test. So if I run this test now, right, now that I have this code here, if I run this now, it's going to be green. And now I know, okay, I have finished that one implementation. I know I've implemented the logic for fizz, and that works. That's been tested. Now I can move on to the next. So now let's say I'm going to test for buzz, right? And remember, buzz was if I have an input that is a multiple of 5, right? That's going to give me buzz. So notice that the test is very much similar, right, to the previous one. Now, I could do a lot of things, like I could change this function to have a different function that actually implements the buzz functionality. I could do all of that, right? I'm just trying to keep things simple for this talk. So I figure, well, I'll just keep it in the same function, but this time I will be entering a different number, which should be a multiple of 5. And this, again, this return value of this should equal to buzz, and that's what this assertion is checking. Okay, so I run this. And then, of course, when I run this, I'm going to run this in addition to this test here as well. And my overall test is going to fail because I have written my buzz test, but I don't have my buzz code yet. Okay, so now my job is to implement the buzz code. Okay, so that's what I'm going to do. So notice that I had my fizz code there already. I've added my buzz, right? And here I said, okay, if you're a multiple of 3, return fizz, otherwise return buzz. Okay, now if I run the test, both of them will pass because I have the buzz logic, which is correct, and the fizz logic, which is correct. So just by going through that exercise, you can see how I'm building up my code. Notice that how easy it is for me to debug the code as well as a developer. I mean, most developers, what they do is they start writing. They write lines and lines and lines of code, and then all of a sudden something doesn't work, and they go, oh, wait a minute, where is the problem? And then they go through this long lines of code, and which takes lots of time to debug and find the problem. As you can see here, every functionality I'm adding, I'm testing it and adding. And my test cases, unless I write it correctly and I write the code correctly, it should not let me add more functionality unless I have implemented the functionality that I'm working on now correctly, right? Huge benefit. Makes you, as we say, it makes you a really good developer. It's like you're measuring things properly, you're thinking about things properly without like just blindly coding. Okay. All right, so I did fizz and buzz. Similarly, I'm going to do implement the FizzBuzz functionality, which takes an input, and then it basically makes sure that that input is a multiple of both 3 and 5, right? So then I go and add that logic, which says, okay, if you are a multiple of 3 and a multiple of 5, then you can return FizzBuzz. And so now I have all 3 of them. So far I've written the test for FizzBuzz and FizzBuzz. Well, and we have written the code for that too. But then now you're going to say, well, what happens if a number is not a multiple of 3 or 5 or both, right? So we need to take care of that, that condition. So I'm again going to write a test case for that. Remember, no functionality is, you cannot write the code to implement a functionality unless there is a test associated with it, right? So then you go and you write a test case to actually test the fact that it is none of the 3, FizzBuzz or FizzBuzz, right? So again, here's an example, and these are basically, we hard code these values because we are testing. These are our test data. So here we're saying, okay, if I am sending in 8, which is neither FizzBuzz or FizzBuzz, I should get 8 back. And that's what I'm testing here. So in this case, I have one last statement that says, if you are not FizzBuzz or Fizz or Buzz, you should be giving me the basically the value that I entered, which is the number. Okay. And this is how it looks like, right? So this is my code, production code. This is what implements the product, right? And these are my test cases. For each functionality that I've implemented, I have a test case to make sure that that functionality has been tested, okay? That's what TDD is. So first thing, like the #1 complaint I get from developers, my God, this is taking a long time. This takes a while. Yes, it does, but you know, good things takes time, that's for sure. It's actually eventually the time that you're talking about evens out. Imagine that if you, and this is a very, very simple program that I'm showing you guys, and most developers would do like way more complicated things than this. So the amount of time you're going to spend debugging code or looking at logic that you probably forgot how you implemented it, finding where the flaw was, without writing these test cases, the amount of time you're going to spend to figure that out, you're better off writing a test case and have that feature implement that way, because then you're actually putting the thought up front and writing it correctly the first time. So you can do things really fast and then spend a lot of time later on fixing things, or you can do it taking some time, putting some thought into it, and then create the product correctly. I will tell you that the latter, taking the time and writing the test cases, provides high quality in the product. It gives the developers lots and lots of confidence, eliminates any kind of requirement, confusion, ambiguity, and all that. Okay, but yes, it is not easy. It does take time to actually do that. All right. So you do need to have some sort of idea about how TDD works in order to move from this to BDD, because they're actually very, very similar. They're implemented in very similar way. Okay, so that was your crash course on TDD. Now let's talk about BDD. So one thing that you hopefully have noticed with TDD is that everything I talked about is component level, right? Unit testing, component testing. Notice that I was looking at, FizzBuzz, and I looked at the smallest component, Fizz and Buzz and all that. Notice that I was given a kind of a requirement that I kind of interpreted myself and came up with these test cases, right? So we call TDD inside out, right? So you're basically going to the core, which is the component, and then you're building the product, and and you're moving out, so from inside to outward. BDD is known as outside in. So BDD looks at top level. So who's at the top level? Who's at the top of the food chain? Our customers, right? So we look at, when you do behavior driven development, we are looking at mainly acceptance criteria, acceptance test cases, all about acceptance, right? So how do how will the customer accept this product? And that's what we want to focus on. So it is, again, a software development technique, keeping testing in mind, using testing as the driver to basically drive the code, develop the code. So here's another interesting, Dilbert-like strip that I found, which I thought was really interesting. Hey guys, I just had an idea. Why don't we try to understand the requirements before we start coding? Which you would think is like, I mean, why wouldn't you do that, right? But that we don't actually do that, and that's why we have a lot of problems in the product, because if we took the time to actually make sure that, can I write a test case for this requirement? If we just ask that question, I think our product would be, we would find a lot less flaw as we go towards system testing. Okay, and again, the main excuse is, oh, we don't have time for that. Let's just write the code, just to get to the code and start building. So TDD versus BDD. So inside out versus outside in. Inside out is TDD, outside in is BDD. As we saw, TDD is automated unit tests, right? And BDD is, again, think of it as automated acceptance test, but it also gives a chance for developers, customers, and testers to work together. Now, TDD, in theory, should do that as well, but a lot of the time, again, it kind of becomes a solo activity. Sometimes developers may ask help from the testers, or if they need clarification on requirements, they may ask for it, but it is still, because you're working at a component level, it kind of becomes a solo activity. But BDD, it actually enables developers, customers, and testers. One thing also notice that in TDD, all the test cases that I showed you guys is actually, it's in a certain language. Could be Java, Python, JavaScript, doesn't matter. So it kind of assumes that if you want to collaborate, you should know Java, right? You should know some sort of programming. Well, we can't really expect that from a customer. Maybe I can expect that from my developers and testers, but I mean, how do I know my customer would know any certain language? So BDD actually provides us the tool to speak the same language, which is pretty much the non-programming language. In other words, here it would be English. So that's one benefit as you start applying BDD to take care of your acceptance test cases. We can actually speak the same language. TDD focuses on the implementation aspect, whereas BDD focuses on the behavioral aspect. So we start seeing how the user is going to interact with the system and how is that system going to behave. That's what our goal is with BDD. So the million-dollar question that people always ask, well, should I use TDD or should I use BDD? And to be honest with you, my answer is you should be using both. Each one of them has different purpose, and they should be used together. So yes, if you are applying BDD, you will see that a lot of the features that you are implementing may already have been tested, right? And that's fine. Then you don't need to write extra component test for those. But there will be other things that are not tested using BDD, and you should be writing, test cases, apply TDD to test those components. So they should be used together, not just, oh, I'm using BDD, therefore I don't need TDD. That's actually not a good approach. So BDD, acceptance criteria for user story should be specified by a test case. And if you are in the agile space, you're kind of, you're sort of on top of this. You have a user story, and the back of your user story tells you your acceptance criteria. If you're not in agile space, you can definitely take a requirement and create acceptance criteria for that requirement. Basically, acceptance criteria would tell you how would the user accept this feature? How would the user accept this product? And you basically write the way the user is going to use the system. You kind of write the test case for that, because if you know how the user is going to use the system or the feature, you're going to write a test case to test it that way. And this test case should be written by, in collaboration with developers, testers, and customers. So again, if you're in Agile, you have your user story in your Agile board, and you kind of flip it and you know what the acceptance criteria is. It's very visible to everybody. So acceptance test documents the behavior of the customer, how a customer is going to use the product, use the feature. So in BDD, we take that concept and we use that to write test cases and eventually write code. Okay. So BDD is very much business facing. We think about our customers more than what how individual developers think the system should be used. One good way to think about this is TDD is like the spark plug of a car, and then BDD is actually the car, right? So if I'm applying BDD, I'm going to have to think about how how a user is going to use the car itself as a overall system with little components that are in it. And if I think about TDD, that's each of these components that makes the car should be tested. So now you can see that it's not really one or the other, it's both, right? You can't just test, if you just test the car and you never test any individual component, you're gonna end up with a lot of problem, right? And if you just test the individual component and you don't test the overall, the whole car as a whole, well, each component may work by itself, but put together, they may not, right? So that's how to think about TDD and BDD, okay? Benefits of BDD, strong collaboration. We do, as you start writing these test cases and eventually the code, you're going to start asking people questions because there's a certain format you need to follow, just like you did for TDD, for BDD as well. There's a certain way you have to write the user stories. So as you start doing that, you're going to have questions, and you're going to go find that business analyst, you're going to go find that customer, you're going to go find that tester and say, well, this is not fitting this format. Is there something wrong with the requirement? Should this be clarified? So these questions, as you know, a defect costs $1 at requirement, cost hundreds of dollars at deployment. So we can eliminate a lot of these defects and problems early in our development life cycle. Of course, the design here, we're going to follow business rules, then our own assumptions. The language, right? We use a language that everyone can understand. It's not Java, it's not JavaScript, so you don't need special training or special expertise in certain thing or certain language to actually understand what the requirements are, how you're going to test this, or how you're going to write code for this. And we're developing based on the user need, which is building the right thing. It does lower cost. Again, it's spread out, right? May seem like, oh, we're taking a lot of time and effort at the beginning, but that also means that there's a huge chance that you're going to eliminate that spending a lot of time later in the development life cycle, okay? So how does it work? So we capture the behavior of the user. And again, that's what our user story is. We capture the behavior and we write it in plain English. And then we basically convert this to automated test cases, test scripts. And then the development team basically then takes these and writes code that passes these test cases. And then the development team can actually refactor, organize the code, write even more test cases to test individual components. Okay. All right, 3 things to remember if you are actually going to implement BDD. We have what's called features, and features are the plain English user stories and acceptance criteria. That's all feature is. We call them feature. And at the bottom is your production code, which is the code that you write where you put the logic and you implement the functionality. Okay. In between is what we call glue code. And some tools, like if you're using tools, it's called step definition. So these glue code, think of these as the test cases, the automated test scripts. So you take the feature, you feed them in the glue code, right? And which means you're writing test cases for the feature. And then, of course, the features are not going to pass, right? Just like TDD, the glue code is going to fail. And then you write the production code to pass these glue code, which are the test cases. And if you pass these, eventually that means that feature is passed, has been implemented correctly. Okay, so very similar to TDD. All right, so let's look at an example so we can all understand how this actually looks, because all of this I just said is great theory, but let's see how it works. So let's think about the same thing we did before is FizzBuzz. All right, so here, notice that I'm using BDD. So I'm going to start with what's called the feature, right? Because I need a feature. So feature, glue, and production. So here's my feature. And the feature says, okay, return of the FizzBuzz, or the FizzBuzz returns. Okay, so I'm basically, the feature could be, write a FizzBuzz application, write a FizzBuzz program. Within the feature, I'm going to tell a story because this is acceptance testing. I'm a user, and the way I'm going to tell you how I'm going to use your product is by telling a story. And the story itself has a certain format, right? And the story goes by, as a something, I want to do something so that some reason, right? That's how a typical user story format is. So here, and again, you just come up with whatever makes you as a user, or you collaborating with the user, makes you understand, make that user story concrete. So here, my user story says, as a math game player, right, I would like to play FizzBuzz so that I can learn how to calculate multiples. Pretty straightforward user story, no assumption. Now you know what kind of user I am and how I'm going to use that feature. Okay, now, given this feature, just like I came up with test cases, right, using TDD, and I had to do that myself, remember? Here, using BDD, it's a bit more formalized, right? And notice this is all in English, just using certain format. So here, from this user story, I can come up with a couple of scenarios. So suppose my first scenario can be, well, when to FizzBuzz, or when we do Fizz. Okay, basically, remember I wrote the first test case, which means test for Fizz. So here we're saying, okay, I'm going to use Fizz, and here the scenarios again have a certain format. The format is called given, when, then. So, and these are actually the tool that you use, and Cucumber is what I'm showing you here, which is a very popular tool for BDD. You have to write the scenario exactly in this format because given, when, then is a keyword. So the tool takes this keyword and it converts that to code. converts that to sort of skeleton test case. So therefore, it's very important that you fit your scenario within that format. So it also makes you think. There's no assumption. You can't just say, oh, I'm thinking how to fizz, but then you have to put it in this format. So here you say, okay, given a FizzBuzz player, when I ask to FizzBuzz for 3, then I should get a fizz. So all this is saying is, by the way, if your input is 3, your output should be fizz, right? So which is very similar to what we just did, but notice here, our requirements or our scenario is very, very clear. Another scenario can be, when to buzz. Given a FizzBuzz player, when I ask to FizzBuzz for 5, then I should get a buzz, right? So, and I can have multiple scenarios based on this feature here. So then I can put all of those together. Well, I'm a lazy developer. I always like to find shortcuts. So guess what? There is shortcut as well. It's not really shortcut. It's more flexible, right? So instead of writing multiple scenarios, I could even do this, which says, notice that this is called a scenario outline. So I kind of have sort of an outline, and I am providing concrete examples to say, well, what happens when I have 1? What happens when I have 2, 3, and so forth? And here, the format is, again, given, when, then. So given a FizzBuzz player, when I ask to FizzBuzz for a value, notice that the value is in angle bracket. And that's because value is a keyword on my example table. And every time it says value, it's going to come here and pretty much apply these, right? And when it does that, I also have a then. The results should come from the display, the display column, and it's tagged by the same column name. And it's going to say, well, when your value is 1, you should display 1. When your value is 3, you should display fizz. When the value is 15, you should display FizzBuzz, right? So, and this is how I create my scenario. Very flexible. If I start creating a couple of this, I should start seeing that pattern, and then I could create this more flexible feature file, right? And now, as a developer, I have a really good concrete idea of how I should implement this. As a tester, you should have a really good idea of what should be your test data and what you should be testing on that, on that feature. All right, so that's my feature file. That's only one step. That's the first step that I've taken. And now, once I make this, clarify this with my customer and my testers and developers, we're all on the same page, I'm going to go and start creating the test case. And that's where the tool comes in handy. It actually gives you a lot of these skeleton code already. And then you go in and sort of put in your own code. So notice that this line here that says, given this tag, this when, and this then, and all of this, all of these code right here, which are basically regular expression, like using regular expressions, they're actually done by the tool. So you don't have to write these. These skeleton names and stuff is done by the tool. All you do is fill in the logic that's inside this parenthesis. And notice that I'm using a lot of the, the assert equals, a lot of the assertions that I've used from TDD in the past. So these are my glue code. Okay, in Cucumber they're called step definitions. So I take my feature and I click the button that creates this skeleton code. Then I go in and I fill in these logic and I run it, and it fails because I don't have the code, right? So then I go in and I put the production code, and notice that this code is exactly what I've done with my TDD, right, in different stages. So again, so then I write the code and I run the test again, and it passes, right? So now I have my FizzBuzz program where it's behavior driven, because I am focusing on how the user is going to use this rather than how I assume they're going to use this. And I'm writing the test case and the production code, right? So it is sort of using the test first approach, but taking the user stories as the requirement. That's where the behavior comes into play. Okay. Tools. So for Java, we use for Java, I use JUnit, but there's the XUnit family. There's the whole unit testing family for doing component testing. Cucumber is the most popular tool that we have for BDD, and Gherkin is the language that Cucumber used to do this. That's done in Gherkin. Okay, so to write the feature file. And then, of course, you can find, Cucumber, you can, if Java is not your language, Ruby is, or Python is, you can find Cucumber support for those as well. So there's actually lots of support for that. Okay. If you guys are interested, again, I said let's try an example together, but I'm not planning on doing this here with you. But just try it on your own, and have a user story. Simple as a user, I want to use my calculator to add 2 numbers so that I can see the total. Right. So if you just take that user story, and I want to apply BDD, right? So I would come up with a scenario. I could come up with multiple scenarios, but I could come up with a scenario that says, given I use my calculator app, when I add, 2 numbers, 17 and 42, then the calculator should display 59, right? And I could even extend this to make a very flexible calculator, and which would look like this. So notice that here, again, I like the flexibility. So here, I would say, given I use my calculator app, when I take first, which is here, second, which is here, and the operation, right, then the calculator should display this. So notice that I have a requirement here, but again, from an acceptance point of view, I'm putting it all together, and I'm actually testing, right? And as I'm testing, I'm also going to write the code, right? But I'm focusing on the different operation that the user is going to apply on that product. So now I have plus, minus, multiply. You can go on and put power and sine, cosine, whatever you want in there. And then you can actually come up with test cases for all of those and start writing the code. As this gets more and more complex, again, there are rules of writing features as well, right? So notice that what I've done is kind of acceptable because it is still within the app. But if I go, it's still plus, minus, multiply, and divide. And then here, it still was within the FizzBuzz, right? So, but if I brought in another functionality, I couldn't add it to here, right? So there are rules of how you can actually write your scenario and feature. They cannot be, they do need to be atomic. They cannot be compound. You cannot mix features together in one feature and implement it. So you do have to put some thoughts into as you're building these features, but there is flexibility as well if you need to. So the one thing I wanted to show you is actually I want to show you this in action. So this is again, these are my test code. This is Eclipse, which is the IDE I use, and I just love it. I just use it for everything. And I use TDD and BDD both, and I use Eclipse for that. So Eclipse has plugin for all of those. So I just download the plugin. And the red-green factor that I was telling you guys, so here, notice that I have a test case that is showing the multiples of 3 and 5. So it's testing for FizzBuzz. And let's say I say, okay, 10, right? And then I just run this, right? And And then notice that this is the red factor. So now I have all this test case. It's going to tell me that it's telling me a very clear visual indication. You have a wrong, like something is not working, right? So then I can go in here and says, oh, look, multiple of 3 and 5, right? It's not working, and it's giving you a very clear message. It says, by the way, it's expected fizz buzz, but now it's just giving you buzz and nothing, right? So that means that this test case, and it's giving me the name of it, multiple of 3 and 5, which is here. So now I can go in here and say, oh, this is not working. So it's going to tell me which test case fails. So it could be the test case, or it could be the code that wasn't correct, and I'll go and fix the code. So if I fix that now, and then I can run it, and notice that I will get a green, right? So any of these test cases, I can have a bunch of them. If it fails, it's going to give me red, which means that's an indication, go and fix things, okay? The other thing I wanted to show you guys also is, let's close this, is my feature file, right? So here is how the feature file is going to look like, all right? So this is the FizzBuzz one. And again, if you do need to spend some time to kind of install and set your environment ready, and notice that all you have to do is just run the feature file. And of course, I have the code in there already. So that's why it's telling me, by the way, these are the scenarios you have, right? And then down here, it's telling me exactly which scenario is being taken care of, which function, right? And at the bottom, it's telling me that you have 12 scenarios, 12 of them passed. You have 36 steps, and all 36 of them passed. And if any of them are not correct, it would actually tell me which one passed and which one failed, so I can go back and fix them. And here are my steps, just like I showed in the on my slides, right? So these are actually created. These lines are created by the tool, and what's inside the braces is what is the logic that I am putting in. And as I finish those test cases, I will basically, write the code to make sure that these, to basically get to this result, right? So as I start writing the code, not all of them are going to pass. Some of them are going to fail. It's going to tell me which one is failing, and then I'll go back and do this, right? So a lot of this part is development. It's developer work. But here, again, the goal is feature-driven, test-driven, and then code, okay? All right, so let's see. Well, in summary, I think I have like 1 more minute left. So in summary, everything that I've covered today revolves around the bottom, which is unit or component, mainly white box, also the top, acceptance criteria, using features and test cases to derive development. Both of these are development strategy, right? So yes, they will help the testers as well. We can definitely train ourselves we will be helping in those creating those test cases. I mean, if someone gave me the feature in that manner, my life is so much easier. I could just take that and convert that to test cases, and at system level, I can apply those to test. None of BDD or TDD, none of these methodologies should be a replacement for system level testing, which is the most comprehensive testing that we do. They're just different ways of developing, putting testing first as the first item, and then features as the first item. Okay, so that was a lot of information for you guys. I will take a couple of questions.
Yeah, great stuff there. If you do want to go ahead and put a question in, go ahead and do so via your GoToWebinar panel. I know one of the questions that's probably popping up in some people's minds is, as a tester, how deeply do you really need to understand, especially maybe on the TDD side? Is that really just for the developers? Where do the testers come into that? I know you talked about that a little bit, but if you could just kind of maybe explain a little more.
So as a tester, right, as a tester, mainly I'm thinking of you as a tester who are primarily responsible for, let's say, testing at system level and probably higher, like acceptance and coordinating that. The using TDD and writing those test cases is probably not going to be your day-to-day job. But having said that, that does not mean that you're going to completely ignore that part and say, that's developer's task, I don't care, and I'm not going to look into that. Because you do want to make sure how all of this it becomes a part of a continuous integration system. So if you have a good continuous integration system, then you will see why your build is failing, and that's probably because there is a component there that does not have a unit test associated with it, right? So these are the things that you kind of want to know how it works, and sort of, what does it mean by component testing? How even the developers write component tests? I think it's important to know the effort that goes into it, in order for you as a tester to appreciate the developers, understand the benefit of writing component tests, how it makes developers better developers and better designer, and how it's going to overall have a positive ROI if you actually implement unit testing and sort of know what's going on within it. So I do think the knowledge will help, but yeah, it's not task of a tester to do this on a daily basis.
No, that's very helpful. And so I would, again, we'll take just one more question here, but if you do have questions, go ahead and follow up and send an email to the reply to for the notification email, and we'll get those answered as well. If you're interested, it's also possible that we can do a follow-up webinar on either TDD or BDD or both. But so here's the last question we're going to take today. It says, do you use TDD and BDD in manual contexts where no automation exists at all, and if so, how?
You can definitely, because as you can see, coding was only a very small part of it, right? So if you're using BDD, it definitely helps polish the requirement, because you are putting yourself in the customer's shoes, right? You are taking a requirement that says, oh, I want the system to be fast. And then how do you take fast and put it under, given, when, then, right? So it does help polish the requirement, remove any kind of ambiguity, set the sort of the roadmap for how you're going to test, what data you're going to use to test, because that's how, as testers, we spend a lot of time coming up with good test cases, applying good design, applying good data set. So absolutely, you can definitely use them in terms of, even if you don't have any kind of automation in place, you can apply the concept for TDD. Given a requirement, actually, as tester, I mean, that's the first thing we think of. We look at a requirement, and the first question I ask is, wait, how do I test this, right? So that's exactly what TDD is. It's just done in a very automated manner. So as tester, we're actually wired to think test-driven. So we actually, we don't call it that, but we definitely do that. Yep. Dave, are you there?
Oh, yeah.
Okay.
Yes, thank you. I wanted to let everyone know, in case you didn't see it in the announcement, that we are recording the session, and that way we will post it, and we'll send an email announcement out to the entire list in case you'd like to show it to your developers or just review some of the details in greater fashion. And if you have interest in additional follow-up information on this, please let us know. So this has been great. I want to thank Dr. Parveen for her excellent presentation once again. And you can see her email address at the bottom of the screen there. You can also, again, reply to the announcement email and ask any questions that you might have. So thank you very much, and thank you for joining us for another ASTQB webinar. We look forward to presenting more of these next year as well. Thanks much.
Thank you, guys. Thank you, Dave.